Today's daily code problem of the day is ugly number part 2, number 264. For this problem, we have an ugly number, which is a positive integer whose prime factors are limited to 2, 3, and 5. Remember, this means that the number's smallest divisible number is either 2, 3, or 5. So, we are given an integer n, and we want to return the nth ugliest number. So if we look at example 1, we have n is equal to 10, so we're looking for the 10th ugliest number. That happens to be 12, because 12's smallest divisible number is 2. We do include 1 in this situation, because if you think about it, 2 to the power of 0 is 1. 3 to the power of 0 is 1. 5 to the power of 0 is 1. So we can include 1 as our prime factors. It's kind of an outlier. It's kind of explained right here. So 1 has no prime factors, therefore all of its prime factors are limited to 2, 3, and 5. So it's kind of included, excluded, it's included. So for this problem, we're going to use a heap or a priority queue. What this means is we are going to push originally the number 1 onto this priority queue. The priority queue is going to store our current number, and then we can use that number to multiply it by our 2, 3, and 5, because those are our prime factors, to get new numbers to add to the minimum heap. We will then use those once again to get the next 2, 3, and 5, so on and so forth, until we get the nth ugliest number. So let's go ahead and program this. First, we're going to initialize a minimum heap. So we're going to have priority queue. And for this problem, we're going to use long as the storage. The reason we're going to use a long is simply because our constraints. We're going to go up to the 1690th ugly number. So this number is going to be pretty big. As we can tell, we're already skipping numbers here. We go from 6 to 8, and then from 10 to 12. It's only going to continue to skip more and more numbers. So the 1690th number will be huge. So we're going to use long to store these extremely long integers. We are then going to have a set, and this set is simply going to keep track of the numbers that we have seen. So the reason we're keeping track of these numbers is to prevent having duplicates in our priority queue. If we have a duplicate in our priority queue, we're going to return the wrong nth ugliest number because no number appears twice in a chronological list. We'll then have an integer array primes, and that's going to be equal simply to our 2, 3, and 5. Those are our prime numbers. Then once, like I said before, we are going to use our minimum heap and offer it 1 as the initial long or integer into our minimum heap, because we will start at 1 and progress from there. So we're going to have 1 and then multiply it by 2 and then multiply it by 3, and then we'll have to multiply 2 by 2 once again to get 4, multiply 1 by 5 to get 5, and then we'll multiply 3 by 2 to get 6, and then we'll multiply 4 by 2 to get 8, then we'll multiply 3 by 3 to get 9, and we'll 5 by 2 to get 10, so on and so forth. So then we can say scene dot add R1. Keep track that we have seen it. We'll then have another long, which is going to be our current. Current is the current number we are looking at. So by keeping track of our current, eventually our current will be the nth ugliest number, and we can return that as an integer. So for int I is equal to 0, as long as I is less than n, meaning we've reached our ugliest number, we are going to take our current, and it's going to be whatever we pull from our minimum heap. So we're going to get the smallest number in our priority queue and use that to multiply by our 2, 3, and 5. So we'll do for int j in primes. We're going to have our long next. This is going to be the next ugly number is going to be equal to our current ugly number times our j. So this is simply taking this current smallest number we have in our minimum heap, and then multiplying it by 2, by 3, by 5. So then the next smallest number would be 2. So we'll take 2 and we'll multiply it by 2, and then we'll multiply it by 3, and then we'll multiply it by 5. So on and so forth until we reach our quote-unquote nth ugliest number. So then we'll check if we have seen this number before. So we'll do scene.add next. If that returns true, we can offer it to, it will return true if we add it to our set. So we can heap.offer next. Otherwise, if it returns false, that means we have already seen that number and it will not add it to our queue again. So current is going to go until I is equal to n, meaning that we have found our ugliest number, and it's going to be the currently pulled from our heap, and it's going to multiply by our primes to get new numbers to add to our heap. So once we get our current to be equal to our nth ugliest number, we can return as an integer current. So if we run this, passes our test cases, and if we submit it, it slowly passes all solutions. So thank you, and follow for more daily LeetCode solutions.